From the Biological Psychiatry family of journals, this is the Biological Psychiatry Podcast, where we discuss the latest research on psychiatric disorders and their treatments. Thank you for joining us. I'm your host and social media editor, Elvisha Dhamala. Adolescents today spend more time on screens than ever before, scrolling social media, playing video games, and using their phones. While concerns about screen time are widespread, emerging research suggests that it's not just how much time young people spend on screens, but how they use them that matters for their mental health. Addictive patterns of screen use, characterized by mood changes and interference with daily life, have been linked to depression, anxiety, and even suicidal behaviors in youth. But what makes some adolescents more vulnerable to developing these problematic patterns? Today, we're exploring groundbreaking research that examines whether differences in brain development during childhood can predict addictive screen use in early adolescence. So, joining me is Dr. Omid Kardan from the University of Michigan, senior author of a recent paper in Biological Psychiatry, Cognitive Neuroscience and Neuroimaging. Welcome to the Biological Psychiatry Podcast.
Thank you so much.
A lot of prior work in this area has focused on screen time rather than addictive screen use behaviors. Can you tell us what the difference is and why that matters?
Sure. Screen time is basically how many hours one generally spends using technologies with a screen interface. And while related, addictive screen use refers to problematic patterns of screen use that include elements of addiction, such as withdrawal, conflict, relapse, and functional impairment. For example, you can have changes in mood when you stop using the device, not being able to stop even if you want to, not being able to focus on your work or your schoolwork, thinking about the gadgets, or when screen use is kind of a frequent cause of conflict with your family.
Your paper mentions that addictive screen use has been linked to serious mental health risks, including suicidal behaviors. Can you tell us a little bit more about what we know about these associations?
The distinction between the total screen time and addictive screen use is actually because some of this emerging evidence that suggests that addictive screen use specifically is more strongly associated with poor psychological adjustment. For example, a recent work by researchers from Columbia and Cornell universities found that between 20 to 30% of American youth that are between 10 to 13 years of age show upward trends in compulsive screen use, as well as difficulty disengaging and distress when not using. And these youth have elevated risk for suicidal ideation and suicidal behaviors at about 1.5 times compared to the other kids who didn't have these upward trends.
You also mentioned that there's evidence suggesting prolonged screen time may be an early sign of neurodevelopmental deficits rather than a causal factor. What does that mean, and how did that shape your study design?
Yeah, so this is to some extent similar to the chicken or egg question. When you see an association between prolonged screen time and mental health or attention problems, you would want to consider multiple scenarios. And for simplicity, I'll mention three scenarios. One is the screen use happens first and causes the increased mental health and attention issues. Two is that mental health and attention issues are happening first and they are causing the problematic screen use patterns. And three is that some other underlying factor is actually causing both of them. So a couple of studies have tried to look into that third scenario where polygenic risk factors and co-twin analysis are used to understand if genetic factors can explain the association between the child's screen time and their mental health or attention problems. And they report that a big proportion of the association is genetically confounded, therefore giving some evidence in support of that third scenario. Now, in our study, instead of genetic predisposing factors, we were interested in neural factors that may predispose addictive screen use. So we tried to predict prospective addictive screen use at a later age by looking at neurodevelopmental factors at an earlier age in a longitudinal manner.
And this study used data from the ABCD study, which is one of the largest brain imaging studies of adolescents. Can you tell us a little bit more about this data set and why it's so valuable for this type of research?
Yes, the Adolescent Brain Cognitive Development ABCD study is an ongoing longitudinal study that recruited over 11,000 children across 21 sites in the United States when they were 9 to 10 years of age, and has been assessing them with behavioral, cognitive, and brain imaging measurements. It provides a very valuable resource for research because of the large and heterogeneous sample with repeated measurements over years, and it covers the period of development when the onset of most of neurodevelopmental disorders occur. And for our study specifically, having multimodal data covering pre to early adolescence period was particularly important.
In your study, you examined two potential neurodevelopmental risk factors: cortical maturation and reward processing. So let's start with cortical maturation. What exactly does that mean, and how does it relate to cognitive ability or performance?
Cortical maturation in our study was specifically about estimating how functionally mature the cortex looks like in an individual youth. Our previous work has shown that some of the improvements you see in a child when they are 12 years old compared to when they were 10, as they perform cognitive tasks, can be explained by the functional communications in the cortex becoming more mature from 10 to 12 within that child. Additionally, some of the individual differences between two kids of the same age in terms of their cognitive performance are also explained by the differences in the degree of the maturity in these cortical communications.
So, is cognitive maturation entirely determined by cortical maturation?
No, but it is definitely associated. And it's kind of interesting point that maybe we'll get to when we get to more details of the study.
You used resting state functional MRI to measure something called the Anchored Functional Connectomic Maturation Score, or AFC. Can you tell us what that measure specifically captures?
So the AFC score is our estimation of the functional maturation of the cortex that I just talked about. To put it simply, every individual has a unique map of intrinsic coordinated activities across their brain regions, and this is sometimes referred to as their connectome. While unique, these connectomes on average go through some systematic changes over development from childhood to adulthood. So with AFC, we estimate to what extent do these expected developmental changes have progressed in an individual user's connectome, and specifically the part of their connectome that only involves cortex.
And how stable are these measures? So, if you scan a child today versus tomorrow, will it be relatively consistent, or does it vary a lot depending on the state that the child is in?
Yeah, so there's definitely some relationships with the state, and you would want to have longer term, like over years, you definitely see changes. And that's one of the things that you want to see in a measure that you use for assessing development. But day to day test retest reliability of the measure is medium to good. And if you have longer amount of data, so more than 15 minutes of resting state fMRI, then it becomes more reliable.
And what does a lower AFC score tell us about a child's brain development?
Yeah, so a lower AFC score, for example, in a 10-year-old compared to their peers, potentially suggests that the cortical functional communications have not matured as far in their connectome compared to their peers. So from a normative growth chart perspective, they have had an overall delayed cortical maturation.
The second potential risk factor you looked at was reward processing. You used a monetary incentive delay task and focused on the nucleus accumbens. Why that region in particular and using this task?
Yes, so altered activity, as in blunted activity or hyperactivity in the reward system when anticipating a reward, has been generally implicated in multiple addictive behaviors, including gambling and substance use disorders. And nucleus accumbens is a key region in the reward system of the brain, and specifically with regards to anticipation of reward. In terms of the task, you want to use a task that is simple enough that the participant can do it in the MRI scanner and also generates a contrast between trials where a reward is involved and trials where no reward is involved. And the monetary incentive delay task is frequently used for this purpose, where at each trial, the participant has to press a button within a short window of time after seeing a cue. And the cue also indicates to them whether some money is at stake for that trial or not. So the button presses and instructions are simple enough to be done while lying in the scanner, and you have brain activity recorded when reward is anticipated versus not, which gives that contrast in the reward system and in the nucleus accumbens in particular.
Can you tell us a little bit more about the sample of participants you were studying?
Yes, so we had, based on the exclusions of the MRI data quality and also whether they had the device, for example, participants who didn't have a phone were not included for the addictive phone use. If they had no social media accounts, they were not included for the addictive social media use. Or if they reported having no video gaming devices, they were not included for the addictive video gaming. Um, Based on these different exclusions, we had slightly different sample sizes, but generally the minimum was 3,400 up to 5,500 participants.
So let's talk about your main findings. What did you discover about the relationship between cortical maturation at ages 9 to 10, or the baseline time point, and addictive screen use a couple years later?
We found a small but robust association such that the youth with lower AFC scores at ages 9 to 10 endorsed more addictive screen use at ages 11 to 13 compared to their peers. And this analysis was adjusted for the child's overall screen time, general psychopathology, and attention problems, as well as their family resources and parental history of substance use.
You also found that lower cortical maturation was most strongly associated with addictive video gaming in particular. Why do you think video gaming might show the strongest relationship compared to social media or phone use in general?
Yeah, so we can speculate about multiple possibilities, but I think one contributing factor, especially related to the addictive social media use, might just be that the age range in our study was not old enough for social media use to be as commonly permitted by the parents compared, for example, to video gaming. For addictive phone use versus video gaming, we do see more endorsement of addictive phone use within the female participants. And in that subsample, you do get the association between lower AFC and addictive phone use specifically.
You mentioned that the phone use was more common in females. Was video gaming more common in males, or was it equally common across both males and females?
Yes, it was much more common in males for video gaming.
So, this association between lower cortical maturation and video gaming, was that also stronger in males, or was it similar across everyone that played these games?
So we didn't find a statistically significant difference in the strengths of the association for AFC predicting addictive video gaming between the male and female participants. We only saw that for addictive phone use.
You also measured cognitive task performance through things like working memory, inhibitory control, and processing speed. What was the relationship that you found between cortical maturation, cognitive performance, and addictive screen use?
Yes, we did find some unexpected results there. So, when focusing on addictive screen use over and above total screen time and general attention problems, performance in cognitive tasks were not significantly associated with addictive screen use. Rather, the participants' AFC score was independently related to both their cognitive performance and addictive screen use.
So, delayed cortical maturation predicted addictive screen use, but actual cognitive task performance did not. What does that tell us about the pathway from brain development to addictive behaviors?
That's a great question that may involve multiple scenarios and needs further investigation. But to keep it simple, I'll pick one of kind of the one that asserts multi-finality in brain development pace. So I think under the conditions of our model, delay-like cortical maturation is part of an underlying neurodevelopmental factor that in some kids is associated with poorer cognitive performance and in others is related to compulsive screen use.
For the reward processing pathway that you looked at, you only found weak evidence linking the lower nucleus accumbens activation to addictive screen use. This is somewhat surprising given that there's a lot of research linking addiction and reward circuitry. Why do you think the reward findings in this study were less robust than the cortical maturation findings?
Yeah, so it could be that the reward sensitivity peaks a bit later in development, maybe around or after 14 years of age. So we didn't have as much power in this younger sample to detect hypo or hypersensitivity in reward anticipation. Another possibility is that the task was not particularly engaging for the kids to evoke the brain response as robustly. It is also possible that altered reward sensitivity is more of a consequence of addictive behaviors rather than a predisposing factor. More research would need to be done to kind of find evidence for or against these different possibilities.
One key limitation that you mentioned in the paper is that addictive screen use was not measured at baseline when kids were 9 to 10. So you couldn't account for how they were using screens in the past. How does this affect how we should interpret your findings, especially when it comes to causality or directionality of these relationships?
Yes, we could only account for total screen time at baseline. We didn't have this particular addictive screen use questionnaires at that time. That means that we have no way to be sure that the reported addictive screen use at ages 12 to 13 were not already present at, for example, 8 years of age. So our results should be interpreted as correlational bidirectional associations until we include further waves of the ABCD study and can account for earlier time points in the model.
On the topic of later time points in the data, how do you expect these kids' overall patterns in terms of screen use and mental health and brain development will change over time? And how might that shape these relationships that you're interested in?
Yes, so I think that there's going to be an upward trend. Usually, after 13, actually, adolescents become more independent or at least want to be more independent, and their parental monitoring on the use of these phones and video games and all that becomes less deterministic for them. So I expect that to increase. Hopefully, future research with other waves of the ABCD can confirm that our neurodevelopmental factors that we have identified here will continue to be predictive for later ages. And that way we'll have a more longitudinal trajectory and can further assess if there are divergence in who becomes more or less predictable with our neurodevelopmental model and whether that means something.
If there's one key message you want parents, clinicians, and policymakers to take away from your work, what would it be?
Yeah, so I think for parents, I would say that even if your children have good cognitive control, you should still consider monitoring their screen use activities. If you see addictive patterns of use, such as mood changes after stopping or failing to meet schoolwork, definitely develop a plan with your child. For clinicians, I would say at this stage, I can't make recommendations. We need more research and better effect sizes. For policymakers, I'm inclined to say don't defund the scientific endeavor. It will only harm the nation.
That's all for today's episode. Thank you to Dr. Carden for joining us to share his work on brain development and addictive screen use in youth. For our listeners, you can find the full paper in Biological Psychiatry, Cognitive Neuroscience, and Neuroimaging, and we'll include the link in our episode description. To learn more about our journals, please visit biologicalpsychiatryjournal.com. You can find the Biological Psychiatry Podcast wherever you get your podcasts. Subscribe now so you don't miss our next episode, and follow us on our social media channels for highlights and updates. Thanks for listening. This podcast is for informational purposes only and does not constitute medical or professional advice. The views expressed are those of the participants and do not necessarily reflect those of the Society of Biological Psychiatry, its family of journals, or its editors. All rights reserved, including those for text and data mining or use in AI systems.